Okay, here we go. Right. Okay, I've been getting used to doing 3 parts to these videos. And I've done loads of stuff to do with fitting all the systems together. But I haven't, have I done XQ? I actually don't know if I've done XQ actually. But what I want to do really now with you is explore some ideas that I've only just kind of glanced at, and I want to maybe, maybe by going through it and exploring the ideas, something new is going to emerge. Okay, because I've been doing all this review of all the different systems, and so we're going to capture that live as we're doing this. So normally it's 1, 2, and 3. In 1, I give you something useful. You choose to watch the second part. You value, comment. You choose to watch the second part. And then something a little bit more advanced occurs. It's maybe more intersubjective. And that's, at the end of that, you choose to share this with another person, like what we shared with you. And then the third part is we're free, basically, to explore even more esoteric or questionable explorations. Explorative, definitely explorative. However, this is all explorative from the beginning. Okay, so because why not? Right. Now I won't be able to actually go into the actual maths of this because it's more, I'm approaching it more like a conceptual thing, right? But effectively, there's a thing called the roots of unity. And it means that on a positive I, negative I, 1, negative 1. So we have the real numbers, the imaginary numbers. We have a circle. Okay, that should be going to 1. Okay, that is negative. That is 1. That is plus I. That is negative I. Okay? Now, the roots of unity basically are based on these imaginary numbers. So imaginary numbers are 2-dimensional, effectively, numbers. And the roots of unity are the roots of unity. So z to the n equals 1. Z. Now, okay. So if n is equal to 2, it's just these two, I think. Yeah, 2. Z to the 2. Z to the 3 gives us a triangle. I can't remember, is it that way? I think it's that way. And Z to the 4 is a square, and I think it's those 4. And Z to the 5 is a pentagon, and Z to the 6 is a hexagon, and so on and so forth. Okay? Can't quite remember. I think, yeah, I'm fairly certain. Alright, I'm going to do it. Okay, so I'm going to have to check online in a second, but that's basically that, like that, and then it goes like that, and then it goes like that, and then it goes like that, and it goes like that. Alright, so that would be Z to the 5. Okay? Z to the 5 is equal to 1, or the other way of putting it is the nth root, and that's why it's called the roots of unity. Z is equal to 1 1 to the 1 over n. Okay, or maybe you're used to this kind of format. Okay, the nth root of 1. Okay, and so this is z to the 5 is equal to 1, which is z is equal to the 5th root of 1. Okay, and there are 5 solutions on the complex plane. Okay, beep, beep, beep. I can't even remember what the numbers are. Right. That position of 0.6 something or other plus 0.89i or something or other. It's one solution, and then they've got these other solutions. Right. Now, that's kind of interesting. The roots of unity. And basically you generate polygons. So this is effectively a polygon. Okay? So it generates a polygon. At 5 is a pentagon. Okay, so that's a polygon. That is a polygon. Maybe I should have done that in red. Okay? So then n gives us the nth root. The nth root of unity gives us an n polygon. Okay, that's the maths. And that's kind of interesting. Okay. And I noticed this quite a few years ago, and I'd be like, oh, right, okay, wow, there's even a thing called roots of unity. And, okay, so I just want to put in a little caveat. The way I think about mathematics is that I don't like negative numbers. I don't like this representation with on a number line with a 0 at the middle. I kind of don't like it. Okay. Because it's got this oppositional spatial sense. It means that I have to think, so when we have something like this with imaginary numbers, it's basically this notion of negative numbers as opposites, and then the I are just projections, conventions, not just conventions, they're very useful conventions that relate up space, that is a two-dimensional surface on the wall here, with numbers. So it relates measurement of a thing with numbers in space. Effectively measurement. So this links to distance. Okay. But because of the fact it's got negatives, it kind of means that I have to perform an additional transformation mentally, which I'd rather not do. So, and because of the fact that I have to do that, it means there's a kind of almost like a mental block. It's almost like a river, and there are two sides to this river, and I kind of get on one side, and I'm like, I'm on this side, and then eventually I get myself to the other side, and there's no bridge. I get myself to the other side, and I go, oh look, I'm on the other side of that river, all right? But when I'm on one side of it, I can't quite see. I can't work out how to get to the other side. Okay. I have to do some kind of transformation psychically. This is all about my psychic process. Okay, when I'm talking about psychosocial processes. So, I don't like negative numbers because they embody this notion of the opposite. Okay, and I'm like, I don't want that. I don't want that. When we're dealing with psychic processes, I don't want the opposite involved. That's an additional construct at a certain level of conceptual development or psychic development that, for example, let's just say it doesn't exist in an amoeba. Okay, it doesn't exist in a dog. Okay, in their psychological construct of what they are. I think. Okay, I'm just making this up. All right. So it's an additional thing. This idea of an opposite is an additional mental structure or function that I would rather not have to deal with. Okay, because one, it's kind of tricky, but two, it doesn't fit for some of our psychosocial engagements. Okay, so for example, the fact that we are together watching this at this moment. So the whole thing about the reflexive presence. Okay, so you and I are watching this, and the person who shared this with you is watching this, and whoever watches this is watching this right now. Now the mathematics of that are a bit tricky. Okay. But there's no opposites. Okay, I am externalizing, I am writing this up, and you're going, oh, okay, and we're experiencing this in time. Now, we might think of different angles and ideas, and anybody who's a mathematician goes, yeah, okay, I know that, yeah, I've got that, I can do that, I can manipulate that. You're like, oh, right, okay, right. So what's our psychosocial condition? They go like, what do you mean? And they won't do the bit that I've done, which is engage a bunch of kids, or here we are, all this together. So right now, there is somebody watching this that actually knows about this kind of maths. They're looking at me like I'm like a fool, is kind of like stumbling around in the dark, and I've only lit up just one tiny little bit of maths, and I don't really know how I got here. That's the kind of fool I am. And they do know. They've got a wider perspective. They know how to get from here through, you know, various other kinds of, a lot of understanding of the these numbers, the imaginary numbers, complex numbers, and they can manipulate and wander about that like they're natural, right? It's a natural thing. Or, for example, there'll be people watching this that are actually into physics and have used complex numbers for the application of to magnetic fields and electric currents and so on and so forth. And they're familiar with that, and they've done this kind of maths because they actually are sitting there trying to generate, and they've created machines, actual physical machines that do stuff. Like computers. They build computers or boxes, electric boxes that do certain things. Various bits of the dam lift or drop or water, whatever. All right, you see, I don't do anything to do with physics. Okay, and I'm not either the person who's just the mathematician who just plays around with this kind of stuff in some kind of abstract space regarding complex numbers. I am a person who engages people. Okay, kids, and here we are together. Okay. And so for those people that can do the kind of maths that apply it to physical objects, go, okay, wait a minute, we're not doing physical objects, it's us. And start thinking about that. And the reason why this is shared with you is because, yeah, start thinking about that. That's what we need. We need to apply this kind of mathematics to us as human beings. Now the physicist, or the engineer, will go, right, okay, well you do this in terms of magnetic fields, okay, currents and so on and so forth. And then they'll apply some of the thoughts about physical nature, about how magnetic fields and currents and the direction of currents and the right-hand rule and all this kind of stuff. And they go, right, so a psychosocial field. And they'll have a tendency for those individuals to import that understanding into us. And start talking about like Lewin in 1947, but he was the guy that started came up with action research, right, way back then, like in the early 20th century. But I think he went on, and this other guy called Brown, I think, came up with the idea of fields, okay, social fields. And he said, social fields. And there were engineer-like people attempting to go, how do we mathematize this? I haven't gone into detail with that because I went, well, they failed. They didn't manage it, all right? So I haven't gone back to that. But, people here might go, okay, I'll go and have a look at that. Lewin and Brown. All right, I'm going to have a look at this idea of social fields. In the attempt, as I think they tried to do, to apply the mathematics for magnetic fields and currents and so on and so forth to us, okay, how we're engaging in meaning. And there might be some richness in that, okay, how meaning is occurring between us at the moment now, okay. It's kind of interesting, yeah? There's a social field, there's some kind of psychosocial field. I'm verbalizing. That is almost like the current, okay? And then there is you guys that are kind of like going along the same kind of temporal, having a temporal experience, having some kind of magnetic field of some kind or other, influenced by my wording, and coming up with your own thinking. And so your own thinking is your own current. So it's like having two wires side by side, and if you pump electricity through one wire, the other wire starts generating a current and a magnetic field around it. Wait, how does it work? It works because it creates a magnetic field around one wire. Okay, why am I doing this? Well, we're exploring, aren't we? That's why we're doing this, because we're explorers. Alright, so if you've got one wire with electricity going through it, it creates a magnetic field around it. Okay, as far as I understand. Alright, and if you put another wire there, that has no electricity going through it because of the magnetic field, it creates, a new, what's that? I don't even know. Right, it's a light bulb. I don't know. Okay, here we go. Right. Beep, 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 beep. So it creates a circuit. Okay, and so using this method, we can induce a current through the magnetic field. All right. So there's something like that parallel going on here, where my verbalization is creating something or other, blah, 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 my meaning, my intention. I've got an intention, and that's kind of what I'm doing in time and verbalizing, blah, 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 and that's kind of almost like a kind of field, I guess. And that field in your own mind, in your own room, and you're just like, ooh, all this is going on, all the associations of thoughts and blah, 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 blah. Oh, okay, and somehow or other you might start getting the meaning of what I'm conveying, and you might come up with different things. You know, light bulb might pop on at some point, okay, which is more significant than anything I'm wittering on about, because I'm wandering about with a tiny little torchlight going, this. Whereas I say, some people are really familiar with this. So, but there's a danger with this, okay? So although that might sound interesting, quite exciting, there's a whole avenue of thought for that. Explore it, please. Okay, I'm interested in the social. I don't want to make that mistake. Okay, because to do that and apply physics and electric currents to us socially and interactions as we're going through time is potentially useful, fine. But because I don't know that and I don't know the maths of that, I'm not going to do that. So if you've got that, you go ahead and do that. Okay. There might be incredible, I mean, really incredible. This is definitely something that should be pursued. All right, pursue this. Okay, if that's kind of interesting to you, pursue it. Create a video, start exploring it. Have a look at Lewin, Brown, and see what they did, because people have tried that. Okay, and maybe nowadays we've got better at it. Maybe we could do it. So the physicists or engineers can do this. Okay, and apply it to our psychosocial condition. Fine, that's what I'm going to do. So. Let's follow what I'm saying a little bit further. Now, the mathematicians that are purely interested in complex numbers and manipulation of complex numbers and this, that, and the next thing, other branches of mathematics, it's all just pure. Pure in terms of this graphic, in terms of two-dimensional space, having some kind of application to the real world, but quite frankly, no, it's just this abstract space, and symbolic manipulation of complex numbers in algebra. Fantastic. Now, those individuals, then I say, right, psychosocially, what are we doing here? And you were listening to the engineering version, and you're like, well, I don't know anything about cables and wires, I'm not particularly interested in that. But another thought's occurred to me, all right? I'm looking at this, and we're talking about psychosocial dynamics. I'm like, oh, and there's another bit of maths, which is related to this, which might be more useful for communication. Okay, what we're attempting to do is get closer to our actual social engagement and how this works. Okay. Now, of course, there are people that are creating computer programs and algorithms for AI. Okay, and they're doing, effectively, it's all neuron-based and complex numbers. It's still like a brute force kind of approach. It's just that they're using simulating neurons, and they've got GANs, generative aggressive, I think it is, generative something or other networks, adaptive, no, generative, antagonistic, aggressive, GANs. Okay, we're going to have to, maybe we should switch on this thing so that you can see what I'm actually searching. Maybe actually, wait a second. We're going to do that. I'm going to do it before. Actually, what time are we on? We're on 18 minutes. Okay, I'll set that up for the next one, all right? Let's just finish off this one. Now, so that means that there's mathematicians looking at this going, okay, so now what we're doing is we're applying it to something. Okay? Now, as I say, there are other people doing GANs, but that's coming from neuron simulation. Whereas we're trying to go for not the actual physical neurons and numbers of connections and everything else, which is what GANs and most of the algorithms that are running currently and networks. What we're interested in is our psychosocial actual dynamic. So we're either these guys, engineers, are thinking of trying to apply that to us, always as objects, but we're not doing the simulation of neurons, our physical neurons. It's something to do with our wording. But again, that's what the GANs are operating on. Usually it's words, structures, and so on and so forth. We're more interested in this internal small bit of how it is that any of it's making any meaning whatsoever. And it's not in the consequential structure. It's in the simultaneous process of thinking and communicating and listening that we are all conducting simultaneously. If you're not sure about this, go and check out the video to do with reflexive reading. Effectively, actually, it's a bit like that, actually. So we've got this, and it's to do reflexive reading, right? Reflexive presence. We're interested in this, okay? And we're trying to, well, I don't know, trying to, somehow or other, and I think that mathematics and XQ, the whole point of XQ, is it reflects some aspect of our mind, okay? And people can get from this to Euclid, what is it? I forgot what it is now already. What is it? E. E to the pi I is equal to negative 1. Okay. And somehow or other, this, somehow the polygon, but circle is related to that. And there's something about how all these numbers fit together. Mathematicians, because they've been practicing it, kind of can. Okay? But I think that's related in some form or other how meaning works and how sentences end up having meaning and how we manage to progress as we go forwards. So we understand something about that, and that's a kind of thing. And we understand what these things are to some extent. And we have an understanding of this and how it fits to other things. And so we have this kind of, I wouldn't say fractal, but we have this globular or modular way of understanding how things kind of fit together. However, we're interested in this bit, okay, this reflexive bit. We're approaching it from a completely different angle, and that is you're actually participating right now. You're not trying to model it, you're trying to go, what am I doing right now when I'm listening, and what is being said, and how my mind's working with words and so on and so forth. But without any modelling, you're just kind of experiencing it and going, and effectively not to model this. And I think that mathematics contains the model of this. So we're trying to look at the mathematics as already being the model of our mind. Okay? So when you're looking at this, it's not a matter that you're applying this to mind, it's more looking at this and going, how does this reflect how my mind works? So this, I think, is a fairly good kind of clue as to how our mind works. But I haven't worked out how. Okay, I don't know if you could see that because of the light. Typical. Oh, in fact, it's good. All right, it's good. There's something hidden there. It's like, what is he talking about? Euler's formula, equation, identity thing. So I'll put it up here. E pi I equals negative 1. Can you see that? Right, no mystery. Okay. So that, in some form or other, is a reflection of our mind in some form. So again, it's not projecting. Okay, we're not going, how can this be applied to our mind? It's more, how does this reflect what is going on here? I think it does, in some sense. Okay? And it's something to do with time, and usually that's represented with pi, as in periods, time, and cycles. Okay, the I, okay, I don't know. I've tried to work out, because this normally refers to something like this, which is a space. Okay, and then we say, this could be something related to time. And you're like, no, this is a spatial representation. Whereas this thing that we're doing right now is temporal. So it's base, we're not wanting to have a spatial representation of what we're doing now. No. Okay. We're wanting to have the mathematics that's actually operating as we are conducting it in time. So it's the mathematical process of thinking. When you're looking at this and the understanding a mathematician has of this, that thinking process that goes on, looking at this and various other associations, that thinking is the mathematics we're interested in. Does that make sense? Okay, the lighting's going a bit off, I'm going to have to change the lighting. Right, so this is kind of the ballpark, and what we're going to be doing in the next bit is exploring another thing to do with dual graphs. Okay, so I'm going to associate this with the next part to do with dual graphs. And we're hopefully going to start approaching this idea of a reflexive presence. Another piece that you might want to start thinking about is the fact that this was given to you, and it was given to you with money. That's a vector intent. You've accepted that, and you're going to make a decision now. Go back to Sqale, put in a value, put in a comment. If you want to go forwards with this, share it with like at least one person. If you don't want to go on forwards, just share it with some other person, so hopefully it finds the right person that is interested in this. That would be good of you. Thank you very much. But those who do want to watch the second part, great, join us in the second part. And at the end of that, you're going to decide whether you want to share this with another human being. And that's another vector, okay? It's something to do with what we're exploring here, and we're hopefully going to synthesize something somewhere in this. Okay, cool. See you in the second part, if you wish to. All right, value, remember, comment.